So I'm going to be showing you how knowing definitions can be a lifesaver in case you're asked a question and you don't know how to solve it necessarily. If you know the definition should be good to go. So if you're asked a question such as find the coordinate vector x relative to a basis b, how do you do that? Well, what's the definition? The definition says that this vector x is essentially the weights C1 up to CP such that x is equal to C1 B1 plus C2, I don't know why I did that, plus C2 B2 all the way up to CP BP. Now the reason that we're using B's is because we're finding x relative to the basis b. So that's why we have b's and not anything else. The coordinate vector x relative to basis b is going to be noted this way, or denoted that way, with these weights. Now if you still see this and you're like, I don't know what the heck this is, I don't know what to do, keep in mind that this looks like something that we have seen many times before, which is the equation that relates to this weight being multiplied by a vector and giving you another vector. And the equation that relates to that is this. x1, a1 plus x2, a2 plus xp, ap, which gives you b. So we know this, or we should know this. If we know this, then we can use this to relate to this. So we're gonna try to use the fact that we have weights x, so weights x multiplied by a matrix to give us this. We have weights c multiplied by a matrix, so x multiplied by a matrix A, C multiplied by a matrix B. All this gives us this, and all this gives us this. So let's use the basis that will be given to us in the question. Let's use the x that will be given to us in the question to solve for this C. One second. So, in the particular problem that I want to go over today, we are given a B1, which is 1, negative 4, and we're given a B2, which is 2, negative 3, and we're given a x, which is negative 1, negative 6. And I'll just rewrite this part. And remember from earlier, we wrote that. So weights C multiplied by a matrix B give us a vector x. And we're looking for these weights right here. If this vector x is not this vector x, never mind. Let's just do it. We're good. Okay, how do we normally solve for these weights when we're given a matrix and the resulting vector? We set everything up in a augmented matrix. So let's do that. I'm gonna do 1, negative 4, 2, negative 3, negative 1, negative 6. Cool. I want this to be a 4, so I can have 4, and a negative 4 gives me 0. So I'm going to multiply this entire first row by 4 and add it to the bottom row, which will give me a new bottom row. This is also a good lesson on row reducing. So I'm going to keep this first row the same. In my head, I'm going to multiply it by 4, because I want this to cancel out. So I'm going to do 1 times 4 is 4, 4 minus 4, 0. 2 times 4 is 8. 8 minus negative 3, 5. Negative 1 times 4 is negative 4. negative 4 minus 6, negative 10. Now we're aiming to have this be in, we're aiming to have this be in reduced echelon form. So let's try to get these pivots to be 1s. So let's divide this by 5 and divide that by 5. And we're going to get a pivot of 1. So the first row is the same. Next row is going to be 1 and negative 2. Now for reduced echelon form, each pivot needs to have a 0 above it, which this pivot does not. So I'm going to multiply that by negative 2, multiply that by negative 2, and add it to this row to give me a new this row. So this bottom row is going to be the same, because this is what we're doing, multiplying and whatever to. So multiplying this by negative 2, I get 1, 0, and 3. Good, so now that we're in reduced echelon form, we can go ahead and write out our solution, which is that our x-coordinate vector relative to basis B is C1, C2, with C1 and C2 being 3 and negative 2. So this 3, negative 2 is going to be your final answer. And that's how you do it.